Today is Thursday, October 11th, and we're continuing right along with Eureka Math 2.6, Module 2, Lesson 6. And you can see our learning goal basically is the same as yesterday. Just like yesterday, we're going to be looking at how we can use area models and how it relates to the standard algorithm and how we can use that to help us multiply numbers. The directions for what we're doing today is similar to what, actually they're the same as what they said yesterday. It tells you to first draw an area model, then solve using the standard algorithm. Then we have to use arrows to match the partial products from the area model to the partial products in the standard algorithm. So start by copying down the problem. 64 times 73. Now I've started an area model for you over here, but it's a little bit different than the area models we drew yesterday. At your table groups, I want you to analyze, first of all, copy down what I drew, and then tell each other what's different about how I drew the area model today versus how we drew the area models yesterday. Yesterday, we kept the factor on the side as one number, 64. But today I split it up into two different numbers, so I had to split the rectangle of my area model again. Do you see I also split it in kind of like expanded form into the tens and the ones? I have 60 plus 4. Does that equal 64? Yeah. So what I'm doing is I know that this whole area, this whole side from the top to here needs to be 64. But I split it up into two sections. This part from here to here is 60, and from here to here is 4. Do you see that? Just like how yesterday I know that this top part, the whole thing all together needs to be 73. But I split it up into two parts where part of it is 70 and then part of it is 3 because 70 plus 3 is 73. So if I wanted to find the area of the entire multiplication equation, it'd be the entire area of the entire rectangle. But by splitting it into the tens and the ones place on each side, it helps us do the multiplication a lot easier. Let me show you what I mean. How would I find the area of this black square right here? How would I find the area of this black square? Niv? I would do 60 times 70. So go ahead and write that inside. We know that because this length is 60 and this width is 70. And we know that to find the length times the width is how we find the area. Okay, let's take a look. I like this because they're both multiples of 10. That means I can just I can ignore the zeros for right now because I have 6 tens times 7 tens. So what's 6 times 7? 42. Then I can look and see how many factors of 10 do I have? How many zeros do I have? How many do I have? 2. So that means how many factors of 10 do I have to add to my product? 2. So what's 60 times 70? 4,200. This time, go ahead and write that partial product inside the box. Don't need to write it at the bottom yet. Okay. Now, how can I find the area of this section, this red highlighted section? Well, I need to first find the length, which is what? 4, okay, and I need to multiply it by the width. What is the width? You know, it doesn't say any number right here. How can I know what this width is? Well, is it the same as this width up here? So what is the width? 70. So to find the area of that part, I have to do 4 times 70. Again, it's a multiple of 10, so I can ignore the 0 for now. What's 4 times 7? 28. And then now how many factors of 10 do I have to add? 1, so I add 1 0. So 4 times 70 is 280. Do you agree?
Yes.
Nice. Okay, now, what about this area right here? Again, I need to find the length times the width. Well, I can see the width at the top is 3. Do you agree? But how can I know the length? Well, it's the same as over here, isn't it? So what is it? 60. So to find the area of that section, we'll do 3 times 60. Again, a multiple of 10. Nice. So I can do 3 times 6, which is? 18. And then how many factors of 10 are there? 1. So I add 1 0. So 3 times 60 is 180. Very nice. Last but not least, let's find the area of this last section down here. Well, what's the length? 4. What's the width?
3.
I love it. It's just math facts. 4 times 3 is? 12. So now I know that the areas are, there's 4 partial products now, right? There's 4,200, 180, 280, and 12. How can I find the total area? What do I need to do? What do I need to do to find the total area? Geffen?
You plus them together.
I do what?
You plus them.
Yeah, close. I add them together. Good. So in order to find the total product, I need to do 4,200, 280, 180, and 12. I need to add those all together. Be super careful when you write them because you want to make sure that you are lining up the place values. So how many ones do I have all together? Okay. How many tens do I have all together? Okay. So we can regroup 10 of them to become 100. How many hundreds do I have all together? Okay. How many thousands do I have all together? So my total product then is 4,672. Now, that's how you can use an area model to solve this. But let's take a look and see how we can use the standard algorithm. Go ahead and write 64 times 73 in standard algorithm setup. The first thing we would have to do is 64 times 3. We can do that by doing 3 times 4, which is 12. Okay, so we'll record the 2 and regroup the 1, or the 10. And then we do 3 times 6, which is? Plus 1 is? Okay. Next, we're working in the tens. So what do I need to put to show that we're in the tens? Everyone? A 0 in the ones place. Very good. Now I can do 7 times 4, which is?
28.
Okay, so we'll record the 8 and regroup the 2's. And then 7 times 6, which is?
42.
Plus 2, 44. Okay, if I add those two partial products together, do I get the same answer? I do. But, you know, the directions tell us we need to draw arrows to show the partial products in the area model and the partial products in the standard algorithm. So where is the 192? Do you guys see any 192s in the area model? Over here I have 4,200, 180, 280, and 12. Which one of those should I draw an arrow to get to 192? Where's the 192? Go ahead and talk at your table group. It's like if I took this slice that I'm coloring in yellow right now. What's the area of that slice right there? 192, because 180, and we can write this out, because 180 plus 12 is equal to 192. So the yellow part right there is the 192. Do you see that? Because the area of that is 64 times 3. Isn't that what we did here? 64 times 3 to get 192? How did we get 4,480? Well, we did 64 times 70, right? Isn't this 64 times 70 right here, this red part? So if we took those partial products, 4,200 plus 280, what would we get? 4,480. Hey, isn't that the partial product right there? So that's where the partial products are. So when it says to draw arrows, what you need to do is you need to show that you're adding 180 plus 12 to get 192, and then draw that arrow, and then 4,200 plus 280 to get 4,480.